We're now going to look at the angles in a triangle as they are asked in coordinate geometry. But we're going to start this lesson looking at question 4, which was the last question in your previous homework. And we have to determine an expression for angle ACB in terms of beta and or theta. Now if we have a look at angle ACB, it's that angle indicated in red on the sketch. And that angle plus theta form a straight line, so they will add up to 180 degrees. So I can represent that red angle as 180 degrees minus theta, and I just use the reason angles on a straight line. For question B, I have to look at angle BAC, which is the angle indicated in green now on the drawing. And if I have a look at that drawing, the green angle plus the red angle plus B are all angles in a triangle, so they should add up to 180 degrees. So angle BAC plus the red angle, which is now written as 180 degrees minus theta, plus angle beta is equal to 180 degrees. So if I want to get angle BAC on its own, I will take 180 degrees minus theta and beta over to the other side, and I end up with BAC is equal to 180 degrees minus my bracket minus B, and I need to multiply that negative into the bracket. So we end up with 180 degrees minus 180 degrees, and then remember minus times minus is plus theta minus beta. The 180 degrees will cancel out, and we're left with theta minus beta. And then angle DAC, which is that angle on the outside. Now if you have a look at it, it's actually the exterior angle to that blue triangle. And the exterior angle of a triangle is equal to the sum of the interior opposite angles. So in this case, the angle outside will equal angle beta plus the red angle. So angle DAC will equal the red angle, 180 minus theta, plus beta. And there's not much I can do to simplify. I can just take away the brackets. So that's just a little explanation of question 4, but we're going to explore this concept a little bit more during this lesson. Okay, let's look at determining the size of theta, which is the acute angle between those two straight lines. And if I have a look, that acute angle outside is actually the exterior angle to that yellow triangle. Now, what information have I got to work with? Well, I've got two straight lines. And the only way those two straight lines can help me is with angles of inclination. That's the only way I can use straight lines and degrees in the same question. So I want to work out angle alpha, and I want to work out angle T. Now angle alpha is going to be the inclination of line G. In other words, tan alpha is going to be the gradient of line G. And the gradient of line G is a half. So tan alpha is equal to a half. And on your calculator, shift tan a half, and you get an angle of 26,6 degrees. So angle alpha is 26,6 degrees. To find out angle T, I need to use the gradient of f. And the gradient of f is minus 1. So tan of T is equal to minus 1. Now remember, because of that negative, I have to work out a reference angle first. So shift tan 1 gives me a reference angle of 45 degrees. And then the negative must remind me to work with the second quadrant. And the rule in the second quadrant is 180 minus. So T will be 180 degrees minus 45 degrees, which is 135 degrees. So angle alpha is 26,6. And angle T is 135, which means the angle next to angle T on the straight line will be 45 degrees. And you'll notice I don't write a reason there. In the section of work, they don't ask you to state reasons, but you can use angles in a triangle or exterior angle of a triangle or angles on a straight line without stating the reason specifically. All right, now we still need to work out theta. So back to my yellow triangle from the beginning. And theta on the outside is actually the exterior angle of that triangle. And the exterior angle is equal to the interior opposite angles. So it's equal to angle alpha plus that new angle indicated with the blue arrow. So it's 26,6 degrees plus 45 degrees, giving me a total of 71,6 degrees. And I've used exterior angle of a triangle, but I don't actually need to state that reason. Let's look at a second example. We need to calculate the size of angle A correct to 1 decimal place. Now the only information I've got is the coordinates of that triangle, of the corners of that triangle, the vertices. So I can use inclinations. So I can use the inclination of AB, and then if I extend AC to the x-axis, I end up with a triangle. Now all I've done is extend the line AC, so I haven't changed its slope. It just makes it a little bit easier to look at, to understand when you can see the drawing. So if possible, try and sketch a triangle using your lines, but using the x-axis as one side of a triangle. All right, so now I've got inclination of AB, which is alpha, and I've got the inclination of AC, which is T. You can use any letters to name those angles. I've just used alpha and T. Okay, so first of all, we want to calculate angle alpha, because if we have angle alpha plus angle A will equal angle T, right? Because T is actually the exterior angle to that red triangle. So to first calculate alpha, I'm going to work with line AB. So I need the gradient of AB first. So the gradient is the change in y over the change in x. So we'll go 4 minus minus 2 over minus 1 minus minus 2. Simplified, 4 plus 2 will give me 6, and minus 1 plus 2 will give me 1. So the gradient of that line is 6 over 1. So to work out the angle of inclination, I use tan. So tan of alpha is 6. So shift tan 6, and I get angle alpha is 80,5 degrees. Let's look at the angle of inclination, T. And to do that, I'm going to use line AC. So again, the gradient is the change in y over the change in x. So y2 minus y1 will be 4 minus 2 over minus 1 minus 3. I end up with 2 over minus 4, which is minus a half. So tan of angle T is equal to minus a half. So remember, you have a negative. So you have to remember to work with the rule in the second quadrant. So I need a reference angle first. So shift tan a half, and I get a reference angle of 26,6 degrees. So to work out angle T, it will be 180 minus 26,6 degrees. So angle T is 153,4 degrees. So getting back to my original statement, that angle T is the exterior angle of my red triangle. So T is equal to A plus alpha. And if I substitute in the angles that I've calculated, T is 153,4. A we want to calculate, and alpha is 80,5. And then if I get A on its own, A will be 153,4 minus 80,5, which is 72,9 degrees. In example 3, we're going to use the same triangle as the previous question, but we're going to calculate B. And I'm actually going to show you two methods for calculating angle B. In the first method, we're going to use the same method as we did in the last question, and that is working with a triangle. So use the lines that you have in your drawing along with the x-axis to form a triangle. So the x-axis must form one side of the triangle. And let's have a look at the inclinations and how they can help us. Well, if we work out the inclination of AB, it's alpha, so we have an exterior angle of the triangle. And if I work out the inclination of BC, I will get theta. Now that's not near my triangle, but if I go vertically opposite that angle, I will get an angle inside my triangle that's equal to theta, which means that alpha, the exterior angle, will equal B plus theta. Now it's the same triangle as the previous question, so I'm not going to do all the calculations again. we did work out that alpha was equal to 80,5 degrees. But now we need to work out theta, and theta is the angle of inclination of BC. So we need to work out the gradient of BC. So the formula for gradient, the change in y over the change in x. So 2 minus minus 2 over 3 minus minus 2. And I end up with a gradient of 4 over 5, which means the tan of theta is equal to 4 over 5. So on my calculator, shift tan 4 over 5, and I get angle theta is equal to 38,7 degrees. So going back to my original statement, that alpha is equal to b plus theta. Remember, we're using the fact that alpha is the exterior angle to the little red triangle. The alpha is equal to 80,5 degrees. B we want to calculate, and theta is 38,7. So if I take 38,7 degrees to the other side, I end up with b is equal to 41,8 degrees. In the second method, I still need these calculations, but I just look at it slightly differently. I'm going to construct a line parallel to my x-axis, coming from B. And if I've got parallel lines, I can use corresponding angles, which means angle theta will be the line between the parallel line and BC, and angle alpha will be the angle between the parallel line and AB. And then it's very easy to see that angle B will in fact be the red minus the blue, angle alpha minus angle theta. So you'll have to do the same calculations as before. Angle alpha is 80,5 degrees minus angle theta, which is 38,7 degrees, giving you angle B is equal to 41,8 degrees. So you can choose your method, and the second method works really nicely if the angle is below the x-axis, where you can use corresponding angles instead of exterior angle of a triangle. Thanks for watching Max Maths. If you liked what you saw, please like, share and subscribe.